Hi, I am Shyam Patel, and now I am going to talking about the introduction of LabVIEW. A LabVIEW is a software in which we use the graphical programming language and data flow. LabVIEW relies on the graphical symbol rather than the textual language to describe the programming action. The principle of the data flow, in which function execute only after receiving the necessary data, governs execution in a straightforward manner. Introduction of LabVIEW. The LabVIEW program are called virtual instruments because their appearance and operation imitate the actual instruments. However, they are analogous to main programs, function, and subroutines from popular language like C, Python, Pascal. LabVIEW contains the two main part. First one is a front panel and second one is a block diagram. In the front panel, how the user interact with the VIs, and in a block diagram, the code that control the program. Every front panel controller indicator has a corresponding terminal on the block diagram. When a VI is run, value from the control flow through the block diagram, where they are used in the function on the diagram, and the result are passed into the other function or indicator. All user interface goes here in a front panel, used to display the control or indicators, highly customizable. The front panel is used to interact with the user when the programming is running, and the user can control the program, change input, and see the data update in a real time. Stress that control are used for the input, adjusting the slide control to set the alarm value, turning a switch on or off, or stopping a program. Indicator are also used as a output. The thermometer, light, and other indicator indicate value from the program. This may include data, program state, and the other information. And the front panel also contain a toolbar whose function we will discuss later. The second one is the block diagram. The block diagram contains this graphical source code. Front panel object appear the terminal on the block diagram. Additionally, the block diagram contains function and structure from built-in a VI to VI library. Wire connect each of the node on the block diagram, including the control and indicators, terminal, function, and structures. In this block diagram, the sub VI temp call the subroutine, which retrieve the temperature from the data acquisition board deck card, and this temperature is plotted along the running average temperature on the waveform graph temperature history. The power switch is the boolean control on the front panel, which will stop the execution of the while loop. The while loop also contains a timing function to control how frequently the loop iterates. Tool palette. It is the part of the LabVIEW software. If automatic tool selection is enabled, and you move the cursor over the object on the front panel or block diagram, the LabVIEW automatically select the corresponding tool from the tool palette. Use the operating tool to change the value of a control or select the next within a control. Use the positioning tool to control, select, move, resize the object. The positioning tool change the shape when it move over the corner of a resized object. Use the labeling tool to edit text and credit free label. The labeling tool change to the cursor when you create the free label. Use the writing tool to wire object together on the block diagram. The next one is the controls and functions palettes. Use the control palette to place the control and indicator on the front panel. The control palette is available only on the front panel. Select the window, then show control palette, or right click the front panel workspace to display the control palette. Second one is the function palette. Use the function palette to build the block diagram. The function palette is available only on the block diagram. Select the window, show the function palette, or right click the block diagram workspace to display the function palette. In a function palette there is so many options in which we select that option, which one which one we use, then drag into the block diagram. That same function perform through the in a function palette. There is so many sub blocks are there. Add structure such as for the while and case structure. First block we can use for loop, while, case structure, and the second one is from the mathematical operation for adding, subtracting, multiplication, etc. And third one is add a boolean operator. We can use the other different type of the gates, and the other is one is a comparison between the two data, and next one is the timing. If we decide the some particular time, that in that time we can use that function. And next one is file IO. In a file IO we use the read to measurement and write from measurement tool. Then we can use the data inside our computer. We can read that data by this tool. And next one, signal. We can generate the different type of the signal by this one. And next one is data acquisition. Here we can use the in a hardware part we use the DAC card that will attach to the computer using USB. Then that acquire the data, and that data we can show by this tool. Next one is the mathematical function, in which block we use the different type of the signal analysis like FFT, DFT, all kind of the function we can perform by this tool. In a function palette there is a sub palettes are there. If we click on that particular tool, function, then it open the sub palette. There is so many different kind of the function are available in both front panel and block diagram also. Status toolbar. There is if we want to run our program, we use that arrow to run the program. First arrow indicate the only one time once we use the we want to run our program. And second arrow indicate the if we continuous run, that will indicate the continuous run button. Next one is if we stop our program, then we can use that button. Next button, push content button. If you pause our program, then we can use this one. Next button show the looking like a bulb, that indicate the how our program work. And the next one, 13pt application font, that it work if we resize our code, then that time we can use that function. And same type of other function we can use, the align object, distribute object, reorders, resize front panel object, execution, highlighting the button, that both white and yellow button. And then step into button, step over button, step out button. Next one is the terminals. When you place the control or indicator on the front panel, automatically create a corresponding control or indicator terminal on the block diagram. Then we can the control the value, and it indicate in the different side. Manipulating control and indicator. The right click on the indicator to change the control and change the format of precision, and right click on the control to change the indicator, change mechanical action, whether to latch open or close, and what to use as a default. Next one is a wire. In a wires is a most important thing in the graphical code. In using wire, we can connect the two different block. There is a example. There is a node and a node to the digital control. The two different digital control connect connect to the node through the wire. A LabVIEW is held together by wire connecting node and terminal that delivers data from the source terminal to one or more destination terminals. Wire connections. The wire transport data through the block diagram. One place to the another place the data will be sent, and wire color indicate the variable type. In a LabVIEW we will use the different type of different colors of wire, which one indicate the each wire indicate the type of variable, and the red cross means something is wrong. There is a code in which there is a red cross is there, which will indicate the some different some wrong wire is placed here. It indicate that. Broken wire. If you can connect more than one source or no source at all to the wire, it indicate through the dash line, which will show the your connection is wrong, and second diagram indicate the perfect connection through the control to the addition block, and gives the output through the indicator. There is a two example, messy versus clean wiring. In a easy to troubleshoot, there is a clean wiring is there, and the second one is messy. What is in a if we connect the all wire, if there is some mistake, then the software automatically indicate where we do the mistakes. Basic wire used in block diagrams and corresponding types. Each wire has a different style or color depending on the data type that flow through the wire. There is a 4 type of wire available in LabVIEW: orange, blue, green and pink. The orange wire indicate the floating point number. If it is a single wire connected, that means one day array, it indicate the one day array, and the same 2 wire indicate the 2D array. Same thing in that blue color wire indicate the integer number, and green wire indicate the booleans, and the pink wire indicate the string. The run button, which looks like as a arrow start the VI, start VI execution when you click on it. And second one is the run button active. It changes the appearance when a VI is actual running. It indicates the how the VI, how each block working. It show the how means it show the flow of the program. And next one is the run button broken. That indicate the when a VI won't compile, the run button is broken. It means it indicate the some error is there. Creating a VI. When you create an object on the front panel, a terminal will be created on a block diagram. This terminal give you access to the front panel object from the block diagram code. Each terminal contain useful information about the front panel object it correspond to. For example, the color and the symbol provide the data type. Double precision floating point number are represented with the orange terminal. In general, orange terminal should wire to orange terminal, and green to green, and so on. This is not a hard and fast rule. The LabVIEW will also allow the user to connect the blue terminal, which indicate the integer value, to the orange terminal, which is indicate the fractional value. For example, but in most case, look for a match in a color. The controls have a arrow on the right side and have a think borders. Indicator have an arrow on the left and a think border. Logic rules apply to writing a LabVIEW. Each wire must have one source or control, and each wire may have multiple destination or indicators. Now the program in this slide taken data from A to A and B, and then passes through the value to the both and the add function and the subtract function. The result are displayed on the appropriate indicators. Both indicators show the both addition value and the subtraction value of the on the front panel. For example, from the function numeric front panel, insert the pair of dice. From the control panel, insert the numeric digital indicator. Use the wiring tool to connect the two and click the run button respectively. The number from 0.00 to 1.00 should be displayed in the front panel. Here in this example, we use the two random number which will multiply by the 5, and that output added to the 1, and that floating value goes through the other addition block, and the same thing done in a parallelly, and both result goes to the add function, and that result show through the numeric indicator. And the next one is a sub VI. After you build a VI and create its icon and indicator pane, you can use it in another VI. A VI within another VI is called the sub VI. A sub VI is a VI that can be used within another VI, similar to the subroutines. Its advantage is modular, easier to debug, don't have to recreate the code, require less memory. Using sub VI helps you can manage, change and debug the block diagram quickly. Here the example indicate the first we create the main VI. In main VI we done that program, 2 number addition, and then result show through the indicator, that making the icon and connector for the sub VI, and after that that program we will use in a different program using by creating the sub VI. In wiring diagram, use selection tool mouse box to select the all item to be in the sub VI. Then from edit menu select the create the sub VI. Then double click on the new icon and save it as a separate VI. The cut and paste it at will or insert is it using function select in a VI menus. Thank you.